Okay, my wonderful students, let's get down to business. Um, Slightly different picture here of mountain climbing the mountain. This one's up in Nepal. It's a beautiful picture. All right. We just handed back your Scantron printouts. I want to point out something to you that is, that needs to be clarified, I guess. There were 45 dots on the Scantron. And one of the questions was a bonus point brain burner. And it was marked that way in the question. I think it said brain burner bonus point or something like that on the test itself. Now that's not number 45. It might have been number 32 or number 18 or something like that. And for every test form, it was different. So test form A, it could have been question 18, test form B, number 37, form C, and so on. So it just depends on which one you got. All right. But I was looking for 44 points. So it's on the Scantron. So it's possible that if you got them all, you got 45 out of 44 on the Scantron. Now, as always, the Scantron percentage is not, well, it's accurate for what it shows, but it doesn't show your exam average because you had some bonus, because you had some clicking points. Now, the clicking, you had an equilibrium temperature question, which was difficult, and that was worth 3 bonus points. So it's possible to have gotten 9 clicking points, 6 regular points, and then another 3 bonus points for the equilibrium temperature. By the way, there was, I'm a little bit, I don't know if it's this section or the online section, but somebody in discussions relative to homework 16, I guess that was the last one, the question about equilibrium, the mixing problem, they just guessed at the equilibrium temperature by saying, well, it must be halfway between the two, which in the homework it was. But that is not always the case. And in the clicking question on the exam, if you look at the blurb sheet, you'll see that the equilibrium temperature was not halfway between the starting and the final. So a lot of you put down 270. You just made that blind guess. You didn't get any partial credit for that at all, because that is definitely, and in discussions, I made a note of it, that this is not a good way to do it, because it's not always going to work that way. It worked that way on the homework, but it's not guaranteed to work every time, and if you don't know how to do it, you're not going to get the exam. I didn't really say this, but I knew that it was going to happen, that you won't get it on the exam, which many of you didn't. The correct answer was 274. 270 ought to have clued you in because it is below the freezing point of water. So you had some water that was going to cool down, and the contention is that the alcohol would not only cool it down but also freeze it, and that was not going to happen. Much more complex calculation. Okay, and the answer was 274 on that one. Okay, the blurb sheets are in web courses on the blurb sheet page for the Scantron printout that you just got. and for the clicking. So you have to kind of remember. Actually, I have the exact verbatim question on the clicking blurb sheet, so you don't have to worry about remembering it. And there's, all the calculations are spelled out in detail on the clicking blurb sheet. By the way, if you would, take a minute to look at your exam printout and see if you have a blank in your rank of answers. See if you have two answers and therefore marked incorrect. And anybody have a blank? Uh-oh. Okay, I want you guys to bring your printouts up to me. We'll try to get them squared away for Thursday, okay? Actually, we might even be able to do it today. Do you have a blank? Okay, you guys with blanks, bring them up right now. Actually, Darian, can you and Caroline, can you try to look through? Give your printouts to Darian, and she'll see if you actually. Now, if you have a blank, if you have a double, who's got a double answer? Anybody have two answers accidentally? All right, you got a blank? All right, give it to these guys. They'll try to sort it out. Hopefully, we'll get that. And students, I think we're going to dismiss a little bit early today, maybe. And so if we do, hopefully we'll have time to hand your papers back. Hopefully we'll get that squared away. Okay, you guys are going to do that? Good, thank you. Do you want some more light? I'll give you that. All right, so you have something to work with. You got a blank? No, I got a double? Yeah. All right, give it to these guys. Okay, Shy, where are you at? Now, when is your study union? Okay, so just to repeat Shy's announcement for those of you that got here late, the SI review session, also known as study union, for the final is Wednesday, April 27th. Who's got a syllabus out? Our final, I think, is the Monday right after that. Tuesday? What is this? Anybody actually have the syllabus? May 3rd? Good. It's 10 a.m., May 3rd, Tuesday. What's that? Shy is also going to record her study union, so that'll be good. Right? And it's 2 hours, right? And what time does it start? 12:30 p.m. So 12:30 lunchtime in the Pegasus Ballroom. Bring your dancing shoes, in case, but definitely bring your thinking caps. Okay, we also have some definite grade news that I want to review with you. And that is, we now have 3 midterms, all of our midterms on the books for almost everybody, except a couple bloopers and a couple, people took the exam special. 174 students. You might want to jot this down. It's a good figure. 174 have taken all 3 exams. That is what I want. There's 220, something like that in here. Some of the SSG leaders boycotted exam 3, which is their prerogative. Now, for those of you, and some of you missed an exam, 1, exam 2, or exam 3 for whatever reason. But 174 of you took all 3. Now, look at this carefully. All right? Of the 174 students that took all 3, their exam average of all three, 71.2%. Now that's right about where I want to put it. 70% is what I usually shoot for. Okay? Now, that's for all three. The problem with that is, that's not what I base your grade on. I base your grade on the best two. Now, here's the average for the best two. 75.5. That, my wonderful students, is what we call, in my homeland of New Jersey, my home planet, that is what we call nice. Because 71.2, that would be a C plus if I was going to give it a letter grade and a plus or a minus. 75.5 would be a B minus. And this shows why, number one, I like this method of handling absences. Two, it shows why it is lovely to push you to take all three by hook or by crook, because I know that this is going to be the case. All right? Some of you may have had a really stinky grade on one of you 174. Some of you may have had a really stinky one and two really nice ones. So your average goes way up. Okay? And the entire class average is good. It should be. You ditch the lowest grade. It's going to raise the average of what remains a little bit. And this one's nice because it goes right across the borderline. Remember, the grading scheme in this class might be different from what you're used to. 50% to pass with a D, 60% to earn a C, the lowest C, 75% to earn a B, the lowest B, and then 90% to earn an A. Now that's normal, 90%. I used to teach with a 92% for A. Some semesters 94% for an A. But here 90% is what we traditionally use. So that's very, very nice. Now, I have some news. Concerning those students who missed one exam. Now, it's not as good. It's all right, but it's not as good. Now, 28 students out of our 200 and something on the books, they missed one, but they got to either 1 and 2, 1 and 3, or 2 and 3. And those guys have an average on their only two exams of 68.5. So you see, now they're doing all right. That would be a C. That would still be a C plus. All right, but it's not nearly as nice as getting a 75. Now, the thing that I want to also point out to you at this point in the semester is that your your clicking participation, we're getting down to it. We have several lectures, but we don't have infinite lectures. So your clicking participation hopefully is up in the area of 24, 25. Same with your homework. Now those two add up to the equivalent of a 50-point midterm, Sava. So if you have 24 and a 25 on those two, that adds up to 49. That's really nice. And if you haven't had an exam grade over 40, for instance, and you take down 49 out of 50 between clicking and homework, those two together, that's pretty nice. It's pretty sweet. But you won't know that until the last official clicking at the end of April, at the end of this month. So we still got several lectures to go. We have several official clicking sessions in lecture. We have several official homeworks, but that day is coming. And when it does, I'll try to post that before the final, so you kind of know where you are going into the final. And one more thing about best 2 out of 3. Here's here's where it's going to be on, here's exam 3, your grade, and that's not posted. It's not published yet. I'll publish that so you can see it. It's in there, but it's on mute for now. Same with exam 3 Scantron. Your best 2 out of 3 is not in there, but I'll try to upload that tonight. You'll be able to know it just by looking at your scores anyways, but I'll put it in there, and it'll look pretty sweet. Here's another close-up. Here's best 2 out of 3 midterms, and it's right above, let me get my cursor over here, it's right above final exam. And yeah, final exam, May 3rd, just like you were saying. Thank you for looking that up in the, I'm talking, yeah. Bueller, yeah. Yeah, okay, that's good. Yeah, I'm looking at grades too. Anyway, so final exam, May 3rd, 10 a.m., that's down here, best 2 out of 3. And in case you guys haven't twigged to it, I've got announcements in the grade book itself. These are all these due dates over here are January 12th, which was the first, it's like 1 a.m. in the morning on January 12th. That was the first Tuesday of the semester. So I hope it's obvious that these are false due dates. I do that to make the grade book, the grades page look nicely. Celine. The 4 bonus points for SSG. Okay, the 4 bonus points for SSG, they're a little bit higher. They're right up here. Okay, and I haven't posted them yet. And actually, Miss Darian and Caroline are probably going to be posting them. Right? I think. Right, but I've got a slot ready for it. And that'll be 4 dinero of bonus points. And then we'll do it again for exam, or for the final. So, question? Hector. Are we going to be using the clicker for the final exam? Jonathan, the answer to that is yes. Now, you won't have to be there, Jonathan, if you do all your SSG activities. But for the rest of us, yeah, clickers on the final, definitely. Yeah. And the reason I like the clickers, among other things, are you can type in a calculation, and if you don't get it right, I can give you partial credit. And students, I gave partial credit for people that came close with their wavelength. You know, the wavelength of H gamma is 434 nanometers. I had a couple people with 435 and a couple with 433. I gave them partial credit. I also noticed a few people with 4.34. I gave them partial credit instead of 434. But that's one of the reasons I like using clickers. So let's keep going here. Okay, so here's the close-up. And just to review, I'll unmute these 2 scores sometime this afternoon, maybe. Now, I want to pause for questions. And yes, go ahead. I don't understand your question. Okay, I understand your question now. And the question was, up here in the second row, are the bonus points for SSG, do they go with the test, or do they just, and SSG bonus points, they just sit there. You've got them. If you earned them by going to SSG, then you've got them. They're not going to go anywhere. I always explain it. It's like, making a peanut butter and jelly sandwich. They start, the peanut butter starts out separate, the jelly starts out, the bread starts out separate, and then you get it, put the peanut butter sandwich together, and then you start, and by the time you're finished eating, it's all smushed together in your stomach. And that's what bonus points. They start out separate, but eventually it all goes into one big number of points at the end of the semester. So just think of them as being attached to your final exam. And so 4 points fewer that you have to do on the final to get an A or a B or C, whatever your goal is. Students, that's for SSG, that's for early iClicker registration bonus. Any other bonus activity, the only exception to that is if I ask a bonus point on a test. That does stay with the test. So if you earned a bonus point on exam 3, but we drop exam 3 and keep your other 2, then those don't factor in. But the SSG, yes. The clicking bonus points for 75% correct, yes. Early iClicker and any other bonus point activity that we do, yeah. All right. Question, yeah. The question was, do we get 4 more bonus points for the final exam SSG? The answer to that is yes. There'll be a separate sign up, a new sign up. So if you went with Jonathan Eisner, you can go with Caitlin Ayala for the final exam SSG. All right. And John and Caitlin and the rest of you guys, SSG leaders, think about when you want to have your SSG. It can be a completely different place. And you may have a completely different squad of 6 students, Angel, that sign up. That's all right. So if you think something might work better, do it. And make that part of your plan, and we'll start getting the sign-up sheets going for that and whatnot. Okay? Other questions? Yes, Amber.
The percentage in web courses up at the top, that's not necessarily accurate because clicking hasn't been factored in yet, right? Correct.
What is your name? Yeah. Jana. Can you kick the back of her chair, please? Because Amber just did a big offense. It's a 15-yard penalty. Play the down over. She asked me about the percentage in web courses at the top. And as I've said about 9 million times, various places in web courses itself, pay no attention to the percentages that web courses spits out. They have no knowledge. I haven't programmed in our grading scheme, 100 points for midterms, 100 points for the final, 25 for participation. They have no knowledge of that. What they do for their percentage is some blunderbuss method of just adding up the total number of numbers that I have in your thing. Now we know that they go how those numbers calculate into a grade, but web courses doesn't. And unfortunately, I cannot turn off those percentages. I wish, by all that's holy, that I could do that. But Canvas it's Canvas's way or the highway. So don't ask me that question. Nobody ask me that question ever again. Even if you're late to class and you forget to put your PID correct, don't ever ask me that question ever. No matter how mischievous you may feel. Okay? Because it drives me insane. Question.
I just want to let you know, some of my teachers actually disabled
Yeah. Well, that's a new development. Ooh. The anti-canvas underground. I'll have to check in on that.
See, if I didn't ask my question, you wouldn't have found that information out. Just saying.
Amber. If there are no more questions, then let's talk about amber. That's right, the mineral amber. Yeah, chemical formula C12H20O1. It's actually a fossilized tree resin, kind of like the pitch that comes out of a pine tree. I love these two images because they have a couple bugs that are fossilized inside the amber. And apparently, bugs are always getting into the pitch of plants and stuff. And but until it's been fossilized for 1,000,000 years, it doesn't actually become a mineral. It's still just pine pitch. It's not really a stone. The Greek word for amber is electron. And there's the Greek letter spelling for it. Eta, lambda, epsilon, kappa, tau, rho, omicron, nu. The Latins used this word, electrum, and succinum for amber. And the thing about amber is that they noticed way back in the days of the ancient Greeks and all that stuff, if you rub it, stuff will cling to it. Like little pieces of cloth, threads, little pieces of paper, or papyrus, I guess. And this is known as triboelectricity. And triboelectricity, there's even something called a triboelectric series. In other words, if you rub a piece of glass with a piece of polyester, the glass will build up positive charge, and the polyester will build up negative charge. Now, the guy that gave us our electrical sign convention, plus for stuff like glass, minus for stuff, well, he didn't have polyester, but silk and stuff, all the different fabrics down here. The person that did that was Ben Franklin. And we now know that electrons are negative and protons are positive. But the glass up here it acquires a net positive charge because it loses electrons. And the polyester down here acquires a net negative charge because it acquires extra electrons from the glass. So they get stripped off the glass and they get grabbed up by the polyester. And you can see that, all you got to do is take a balloon and rub it on your shirt and it'll cling, it clings to the wall or it'll cling to your shirt, it'll cling to your head, you can walk around with a balloon on top of your head and stuff like that. Tribo, that comes from the Latin word tribulum, which means threshing sledge. Back in the day, before International Harvester, they had to basically whoop up on every sheaf of wheat to knock out the grains of wheat. And then the chaff would blow away, the dense kernels of wheat. And that's called one of the devices they used was a sledge called a tribulum. The word tribulation also comes from the sense of being, totally thrashed and in total danger, from the same word, tribulum. But anyways, triboelectric, it means to rub, to be thrashed enough to, by rubbing, that it develops some surplus negative or some surplus positive charge. Now, one of the things that we do in the present day is to avoid that, we use cling-free. You put your socks in the dryer or a load of t-shirts or whatnot, and if the conditions are right, and you don't put in some cling free or some bounce or something like that, or the generic stuff from Kmart or from Walmart, then your socks will be stuck together. You get sparks. If the atmosphere is dry, actually the atmosphere is really dry today, so you can get electric sparks and stuff if you don't use cling free. And so, why am I talking about amber? I'm talking about amber because um, it is the first sign historically that we noticed the concept of electricity. Electron, comes from the Greek word for amber, and through that, the Latin word electrum. And so we're starting to talk about the electromagnetic interaction, the Coulomb interaction. Step one, amber. Step two, lodestone. Here's a picture of lodestone. Look at those little fibers up here. Let me turn off this light. Look at these little fibers kind of sticking up here on the northwest corner of this rock. This is a piece of lodestone, and what they found was in the days of the ancient Greeks and stuff, iron was the hot tech. Iron in those days was like a rarity. If you could have some iron, that was like a strategic metal. Now today, iron is as common as dirt. But in those days, iron and bronze were considered precious metals because you could use them for weapons and for all kinds of other stuff. And they noticed that these little grains, these little filings of iron, to make something sharp with iron, you have to file it down. And you would have these little shavings. And they found that on certain pieces of iron ore, it would accumulate and kind of draw those filings. And notice that all these little filaments, these little filings, they're all kind of oriented outward from the rock. They're approximately perpendicular to the surface, wherever the surface happens to be in this view, right? And this is what we call a lodestone. It's a special form of magnetite. Magnetite is an iron oxide. Its chemical formula is Fe3O4. It's the best of the iron ores. There's a couple others that people mine, but magnetite is really good iron ore. Not all of it's magnetized, but a lot of it is. Fe3O4 doesn't have to be magnetized, but a lot of it is. And up in, for instance, the Mesabi Range in northern Minnesota, here's a picture of northern Minnesota. Here's Lake Superior. Here's Canada. And I've camped all through this area here. This green down here is Wisconsin. This iron range, it also extends up into the northern peninsula of Michigan. Lots of iron ore up there. And there's other places in the world where there's a lot of iron ore. This is in the United States, yep. We got tons of it up there. And those mountains are not that big. They're very, very old mountains. But it just happens to be that the geology of those mountains has, or that they formed geologically with a lot of magnetite. Magnets, they're named after Magnesia in a district of Asia Minor on the Mediterranean Sea, which is where they found some of the first magnetite. First compass needle, we think, was made by guys in China. They tied a little sliver of it, a little compass needle, a little needle of it, a little thin slice of magnetite to a string, and then let it orient itself to Earth's magnetic field, and they found that it always aimed in the same basic direction. And that is how a compass works. And in this present day, a compass is you can get it anywhere you want. You can probably go to, well, I don't know, probably not Walmart, but if you go to a camping store, you could probably get a compass. And I have a bunch at home. And they're detectors of the magnetic field, magnet. So the question comes to mind, how do you detect the electric field, that we first noticed with amber? How do you detect the magnetic field that we first noticed with lodestone? Well, in the present day, a very simple detector, of course, is the compass. And you can make a compass with a little, see this red and white bar here? It's a little, very light piece of steel, and it's been magnetized. It's been magnetized so that it'll swing in the direction and it'll align itself with the magnetic field of Earth and therefore indicate the direction north and south. And it's in this particular compass, it's inside this plastic housing, and you can see that it's got a little protractor built into it, and it's got rulers over here, and it's got kind of arrows for lining things up. This is what somebody would do if they're trying to find a course through the wilderness, or what do they call that sport? Not surveying, but orienteering, or geocaching. You use the GPS device, but orienteering, finding your way through an unknown territory by compass and pacing your distances off, yeah, you can do that with this. Here's another example. If you've ever seen one of these pile drivers driving piles in to the soil of Florida or any other place, the pile driver is usually going to be driving piles made of iron or steel. Okay? And you see them all over the place. And probably there's piles that were driven in for this building. And what is kind of curious, when you bang on a piece of iron, it'll rattle all the iron molecules. See, the thing in a piece of iron that makes it magnetic is the iron atoms. They'll all tend to line up in a certain way if it's magnetized. All the magnetic, little magnets in each iron atom will tend to align in the same way if it's all magnetized. And the way you can do it is just hammering on it. And see, because what happens is, if you have a piece of iron and you hammer on it, it'll rattle all those iron atoms. But then they'll settle down and they'll orient themselves closer to the Earth's magnetic field. I mean, if they started out with random orientation, they just came out of a blast furnace or something, okay, and then they cooled off, you got a piece of steel, and they start banging on it, they'll jiggle around and it'll get closer to the magnetic field of the Earth. Bang it again, even closer. Bang it again, even closer. And that's what happens with these pile drivers. The reason I know this from direct experience is, when I was in grad school, they put up a new building at Montana State. The EPS building, very fancy, lots of cool labs, and office space for grad students that was really nice. And it took them a year to do it because they had to drive in these pilings for some reason. I guess to keep it ultra stable for optics and stuff like that. Anyways, so they had these big pilings in there, right? And for months, there was this big pile driver, just like this one in the picture, driving those piles, bang, bang, all day. You could hear all the way across campus from our old building. Bang, 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 they go. And nobody thought anything of it. And they got all the piles in, they, got the whole structure up, and they put the carpeting in, they put in the windows, air conditioner, everything, lovely office furniture for us grad students instead of being in a sardine can that we were previous to that. So they got it all fished up, and I brought my Mac, and in those days we didn't have these flat screens. We had the old time, monitor, like a color TV, the kind that sticks out, a mile and back. It's got a big electron gun in the back of it. Well, those things have big magnets in them. And they use the magnetic field to steer the electrons. And I was in my office with my computer monitor, and I noticed that my computer monitor was tilted. The display was tilted by about 5 degrees. Because the desk I was using was level, the floor was level, and therefore the bottom edge of the monitor was level. But the display was rotated about 5 degrees. And I said, what the? And somebody said, oh, wow, you got a magnetic field there. So check it out. I brought my compass in from home, that I usually use out in the wilderness. So, climbing mountains and whatnot. And so I brought it in, and I'm walking down the hallway with it. It's a big, long building. The hallways are about 100 meters long. He's going to miss a clicker question. So you got this is a big building. So I'm walking down the hallway, and my compass needle, it's supposed to be going towards the north. It's all over the place. And then I walk in the office. I walk through the office door of my grad student office where I have about 6 other guys in there. And I walk through and the compass needle goes all the way around in a circle. It's like I just walked all the way around the north magnetic pole of the Earth. That's what it would do. And I thought, oh my God, this is astounding. It's this huge magnetic field right here in my office, just going through the door. So then I talked to the other guys and some of the professors and stuff, and we figured out that it was these piles, when they were being driven, they were remagnetized. So this big physics building, hot laboratories and everything, they had to go, because we'd just been in for a few weeks. And I was the first one to notice it. And they had all this really sensitive equipment that they had to now go and revise and remodel to adjust for this magnetic field. It was a big disaster. Battleships. If you're in a shipyard, those things are made of iron. They're made of steel. All the hammering and riveting that goes on with those babies, they'll get remagnetized as well. And ships have to compensate for an enormous inbuilt magnetic field because they have to run electronic equipment. They have to have a compass for navigation. It's complicated. Magnetic field. So let me ask you a basic iClicker question. Go ahead and turn on your clicker, if you please.
Dr. B,
Yeah.
is that permanent? Like
Yeah.
It is.
Well, until you bang it again, you can redo it.
So that's why they had to recalibrate everything.
Yeah, because it was already built. They couldn't go and do the piles again. I mean, it wouldn't be productive. So, yeah. So they basically wind big coils of wire around their devices and counteract that magnetic field with another one. It's crazy, but that's what they had to do. Okay, clicker question number 1 for today. Frequency BB. Which of these machines, devices, or substances? Go ahead and vote. And there's a picture of magnetite crystals to look at. Geology.com has got a lot of good stuff. Just like webelements.com. $15 seconds. Yeah. If you heat them and reheat them, they'll lose their. Yeah, because the iron atoms will eventually they'll become disorganized. If you heat it up, they'll become disorganized. Because heating, it's just not just random motions of velocity vectors, but also for iron atoms, random directions of orientation. So they'll eventually become more disorganized. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Oh ho! 9% for option A, 49% for option B, 0% for option C, 1% for option D, and 41% for option E. Did you guys figure out all the blanks and everything? Okay, did you record the new grades? Nobody changed? Okay. You guys that have your exam printouts up here with blanks and double answers, nothing changed. Everything checked out. No change. But you come up and get your printout at the end of class. Anyways, back to this. Yeah, emergency generator. Yeah, so like, yeah, so, okay, so go ahead and let this be part of your notes for today. Emergency generator, it runs off gasoline, right? So, but inside the generator is a magnet. And the magnet spins. And surrounding the magnet, or inside of the magnet, maybe, I guess, is a coil of wire, another coil of wire, that in which electric current is produced. So that's the correct answer, but GPS also. GPS. How? Hey, how do you even know that you've got a GPS signal? It's electromagnetic. It's a radio signal or gigahertz, whatever the frequency is. It's electromagnetic radiation from those satellites, 3 of them preferably, to your telephone. Your telephone works electromagnetically. It would, and if there were no electromagnetic unity, if they weren't unified, there'd be no electromagnetic waves. Monster, nobody voted for it, but this is the most complex answer of all. Now listen. Monster, the bubbles that form, the sweetness that you experience. You're experiencing the effects of atoms and molecules, and those are governed by the electromagnetic interaction. It's Netflix, also correct. How do you even get Netflix? Electrons blabbing inside your computer. The electromagnetic interaction. It's all got to work. So the correct answer is actually E, but I'll give you all points for that one. All right, let's dismiss early. I'll give you a little homework tonight, number 17. You're dismissed.